Over the years, we have realized that there are a lot of people who do not really understand how cars work. So apart from our Project Car series, we have decided to roll out a series of educational videos meant to give you a better understanding of how cars work. This series is meant to cater to all types of viewers across our different videos. And I hope to inform the less informed about what really goes on in your car, what's important and what's not so important. I will also be covering some more advanced and potentially controversial topics later on for the more advanced viewers to debate about. So on to my first topic of the series, how do cars work? A car is basically a collection of many different systems that work interdependently with each other as one unified machine. Just like our bodies are made up of many different organs, a car is the same, where it has many different systems, each performing a specific function in order for the whole car to run smoothly. For today's video, we will go through an overview of the many different systems found within a car. Many of these systems consist of their own subsystems, but we'll go into more detail on that in later videos. So the main systems commonly found on cars that we'll be going through today are the chassis, the engine, the transmission, the braking system, the suspension, and the electrical and electronic systems. The chassis is the skeleton of the car, not to be confused with the bodywork, which is more like the skin of the car. So your typical road car chassis is generally made up of a structure of beams and rails bolted or welded together to create one single shape. Literally everything else on the car is bolted directly or indirectly to this chassis. The chassis is largely responsible for the stiffness of the whole car for the sake of handling as well as structural integrity in the event of an accident. The exception to this design are cars that use a monocoque design. Now this is usually found only in race cars or really high performance supercars. So the engine is the heart of the car. It provides the power to move the car as well as the power to generate electricity for the battery and for all the electronic systems. The most popular type of engine at the moment is the internal combustion engine, also known as the IC engine. But this does look set to change, however, in the next 10 to 15 years with the global push for cleaner emissions and clean technologies. The engine itself is made up of many other subsystems. Modern IC engines still work on pretty much the same principle that they do when they were invented over 100 years ago. They have, however, been refined and developed over the years to achieve greater power output and greater fuel efficiency. The engine also helps to generate electricity to run the electrical components as well as to recharge the battery while the car is running. So how do we get the power from the engine to spin the wheels of the car? Well, that is the job of the transmission, also known as the drivetrain. But why do we need a drivetrain? Why can't we just connect the engine directly to the wheels? Why do we need a drivetrain? Well, that is because the engine spins at a very high speed of thousands of revolutions per minute. This makes it impractical to directly connect the engine to the wheels because the wheels will just keep spinning and spinning and spinning non-stop. And the moment the wheels stop, the engine dies. Hence, an intermediary connection is required to control the speed and the torque of the engine being transmitted to the wheels. The transmission itself also consists of its own subsystems, such as the gearbox, the drive shaft, the propeller shaft in some cases, the clutch, and many more. Exactly how the transmission works, we will go through in more detail in another video. Now, with all that power being supplied by the engine to the wheels, we need a safe and effective way of slowing down and stopping the vehicle. This job is primarily done by the braking system. The idea is that friction is applied to a piece of componentry attached to the wheel so that it slows down the whole vehicle. This frictional clamping force comes from the brake pedal pushing hydraulic fluid through a series of hoses, which thus amplifies our foot pressure onto the pedal. So the integrity of the braking system is of utmost importance to the safe operation of the vehicle. Hence, it is a mandatory requirement by law to be of a certain force, and it must even be equal on both wheels. So, beneath all that power and technology, the only thing that really connects the car to the road are actually 4 rubber tires. The idea of keeping these 4 rubber tires firmly planted on the ground is one of the single most important factors in designing a well-handling car. And the job of that falls mainly on the suspension. The suspension is more than just providing comfort for the passengers in the car. Its real function is actually to keep the car stable and in control on the road. It is therefore no surprise that suspension design and tuning is one of the single most important things in professional motorsports, easily equal to that of the engine, if not more important. There are several types of suspension designs commonly found on most road cars, each having their own pros and cons. Some have better characteristics at the expense of weight and complexity, while others are lighter, simpler, and cheaper to produce. So the choice of suspension design is mainly down to the ambitions of the vehicle that the designer is trying to create, as well as the cost that they are trying to achieve. The electrical systems in cars these days are quite complex. In the past, all we needed the battery to do was run the lights, run the wipers, run the ignition, maybe the radio, maybe the air conditioning. These days, the electrical systems are essentially a whole computer system that monitors every single component in the car, from the engine to the suspension to the brakes, even the tire pressures and the weather. So by monitoring all these various things, the computer is able to optimally adjust everything on the fly so that you get the most optimal and most efficient ride. As a result, we now have safer and more efficient and cleaner vehicles. The downside, however, is that repairs tend to be a lot more costly these days as compared to how they were in the past. That is because nowadays, you do not change just a mechanical component, you change a mechanical with an electrical component attached to it, because everything is being monitored in the car. To a certain extent, it has also become somewhat more difficult to troubleshoot any issues due to the complexity of the systems involved. Repair shops now have to be equipped with specialized tools and diagnostic systems, because every car nowadays has a built-in computer that you need a specialized software to plug into, and not all the time will this computer give you back the exact error that is happening. A lot of times, an unrelated issue is actually triggering a certain error, and we will have to find out what exactly the real issue is that's causing this error. Overall, while these modern electronics do bring about certain issues, you can't deny that they have improved the quality of the vehicles that we are driving these days. So to conclude this video, a car is simply a collection of very carefully thought out systems put together. By understanding the functions and requirements of these individual systems, as well as the vehicle as a whole, we can therefore make better decisions when we want to modify, or want to repair, or want to service, and whether to decide what to prioritize and what not to prioritize. So in our upcoming videos, we will go into more detail about these individual systems that we presented here today and how they function and how they work. I hope you enjoyed this video and I hope you've learned something from it. Please click the like and subscribe button below, and I'll see you again next time.